Let's talk about sequence and series. As we talk about this topic, we will be making use of the PDF book Pre-Calculus. Now, when we talk about sequence, we're really looking at number sequence of numbers. And a sequence is an infinite list of numbers. Now, let's go to our book, our textbook that we'll be using for this. So, the sequence is an infinite list of numbers. The numbers in the sequence are often written A1, A2, A3, and so on. Alright? What I recommend you do is not just watch the video, but read the book separately from watching the video, and then watch the video as well to go through whatever material that you might miss or might misunderstand, right, and post any questions that you have. So this is an example of a sequence: 5, 10, 15, 20, and so on. 5 is referred to as A1, A2, A3. So the first term here is 5. This is A1. The second term is 10, which is A2. So here you have these terms in the form AN, where N is the position of the term. In the first term, N is 1. In the second term, N is 2. In the third term, N is 3, and so on and so forth. Alright? Now this sequence, let me increase our zoom. This sequence here, the pattern of the sequence, it follows this formula. And remember, there must be a pattern, a fixed pattern to a sequence, and there must be a formula or some rule that the sequence follows. In this case, we say it's 5n. What that means, the first number is 5, which is 5 times the position is 1. In the second number, it's in position 2. It is 10, which is 5 times 2, which is 5 by 2, 5n. The third number, A3, is 15, but guess what? The position in the third number is 3, and you multiply 5 by 3 to get the 15. The fourth number, in position number 4, you have 5 by 4, which is 20. And 25 is in the fifth position, A5, 5 by 5 gives you 25. So the formula that governs this sequence here is 5 times n. So they write it here, an equal. It means the number in the nth position is 5 times n, whatever n is. Alright? Now, you may have already thought of a different way to write the pattern. You could go from one number to the next by just adding 5. So you could say 5 plus 5 gives you 10. 10 plus 5 gives you 15. 15 plus 5, 20. 20 plus 5, 25, and so on and so forth. So this natural way of describing the sequence is called recursive. Re means it happens again. Alright? So you have the first number, and then you add 5 to get the next number, then you have 5 to get the other number. If you have the 30th number, you add 5 to the 30th number to get the 31st number. So you start with a certain number, then you add 5. That's what this means. Now as you read through this book, when you see this, an is equal to an minus 1 plus 5, what does that really mean? What happened? If you are at the 30th number and you want to know what the next number is, then A, which is 31, equals the number before it, which is A, n minus 1 would be 31 minus 1 plus 5. The number before it is 31 minus 1, which in this case is the number 30. 31 minus 1 would give you 30. So if you have the 30th number, whatever that is, the 31st number would be that 30th number plus 5. Alright? Then of course, the 32nd number, A32, would be A31 plus 5. So if you choose to keep adding 5 to the next number, this is what you would get. So if you start with 5 and you try substituting n as 1, 2, 3 and so on, you see how they produce the numbers in the sequence. We did that already. N is 1 is 5 times 1, when n is 2 is 5 times 2, and so on and so forth. Alright. I'm not going to be reading through every detail, every word and letter of this textbook. You should sit down and carefully read through it. What we're going to be doing is concentrate on the most important points. Now, a sequence, what is that? Any ordered. It must be in order, whether it's going up or going down. Any ordered list of numbers can be viewed as a function whose input values are 1, then 2, then 3, and so on and so forth. The dots mean the list goes on and on. The input values are the numbers in the list. Alright? Now, definition of a sequence. Let's erase this. A sequence. Now you need to make a note of this point in your notebook, very important. A sequence is a function A. That's a letter, a function A, whose domain, that means whatever number you put in that you're going to base your calculation on, whose domain is the set of natural numbers. That means you put in certain numbers and you're going to do your calculation to get out other numbers to make the sequence. The terms of a sequence, A1, A2, A3, well, they're generally not written with the numbers in bracket. So they're written usually as a subscript, the numbers being subscript. So you have A1, and you have A2, you have A3, and so on. AN here means whatever position you reach. N can be any number, whether it is 50, 80, 100, 300. N can be any number. Now you start at A1, then the second term is A2. A is the letter generally used. You might see other books, other websites that use a different letter, but it's generally A that is used. Alright? So the number A1 is called the first term, A2 the second term, and so on. So the nth term would be AN. For example, the 50th term would be A50, and so on. Alright? So this book presents you with a general example. Let me me erase some of what I wrote here. Well, at least all of it. Here now, you have a simple example, 2, 4, 6, 8, 10. Now, you clearly see, well, you have to look at it carefully and think about these numbers first, right? In order to find out what is the rule that they follow. What rule do these numbers follow? It's given here, but let's not look at this yet. 2. The first number is 2, A1. You have the second being 4, which is A2, and so on and so forth. Now, how could you possibly get A1? Could it be that you take 1 and multiply by 2? And could it be that the 4 comes from 2 multiplied by 2? Could it be that the 6 comes from 2 times 3? The 8 is from 2 times 4. Remember, 1, 2, 3, 4. Those are the positions of the number. First number is in position 1, second number is in position 2, third number is in position 3, the fourth number is in position 4. 2 times the position give you these. It seems to be working. If you look at the fifth number, it is in position 5. Multiply 2 by 5, you get 10. Now we see that in order to get these numbers, what you do to get the nth term, right? Remember, these are first term, second term, third term, fourth term, fifth term. So to get the nth term, you multiply the position n by 2. And that's what they did to get an is equal to 2n here. So that should be clear, all right? So there you go with that. Now, let's look at something else. Let me erase what I have here. Good. Let's look at these. This sequence can be written as, you have 2, 4, 6, 8. So these are the first term, second term, third term, fourth term. And then the nth term is 2 times n. So this is the sequence that we saw a while ago. Alright? So notice how the formula an is equal to 2n gives all the terms of the sequence. So a1 is 2 by 1. That's what we did a while ago. It's 2 times the position. A2 is 2 by 2. A3 is 2 by 3. A4 is 2 by 4. So you have 2, 4, 6, 8. Now they ask you for the 103rd term of the sequence. That is when n is 103. All you do here now is multiply n by 2. It's 2n you're looking at. So 2 times 103 will give you 206. 206. Alright? Good. So we have 206 here. Now, we're going to look at these examples. Find the terms of the sequence. You must find the first 5 terms and then the 100th term of the sequence. Let me write it around here on my whiteboard. An is equal to 2n minus 1. So you have an is equal to 2n minus 1. Notice I made some jottings here. You have a certain rule that they follow and a pattern that the sequence follow. The number A1 is called the first term, A2 the second term, and so on. So in general, AN is called the nth term. We have A and then subscript N. Now you are asked to find the first 5 terms and the 100th term of the sequence defined by each formula. Now, I'm going to ask you to work this out, but do not look at the textbook. Do not look at how they do it. Alright? Work it out on your own. Let me paste the instructions here. So, take a minute to work this one out. I'm going to also have B, which is Cn equal. So you see, you can use An, you can use other letters, Cn, Tn, Rn, and so on. Cn is n squared minus 1. So, Cn is equal to n squared minus 1. The next one is Tn equal n over n plus 1. So Tn equal n over n plus 1. Let me rewrite the T there. Let me write it more slowly. Tn is n over n plus 1, and then Rn is negative 1 to the n over 2 to the n. So Rn is equal to negative 1 to the n divided by 2 to the n. Good. Solutions. They have the solutions here. I don't want to scroll to the solutions. So we're going to pause, or we're going to end this video here. We'll continue in the next video, but don't look at how they do it. I want you to sit down and find the first 5 terms and the 100th term of each sequence. Do it on your own, and then we come back and continue and look at these things in the next video. A, B, C, D. So go ahead and do them, and I'll see you in the next video.